Hello friends, in this session we'll see 7 principles of software testing. Let's begin. Software testing is a procedure of implementing software or the application to identify the defect or bugs. For testing an application or software, we need to follow some principle to make our product defect free. And that also helps the test engineers to test the software with their efforts and time. Here in this session, we are going to learn about the 7 essential principles of software testing. With the help of this diagram, you can see 7 principles of software testing. First one is testing shows the presence of defects. Second one is exhaustive testing is impossible. Third one is early testing. Fourth one is defect clustering. Fifth one is pesticide paradox. Sixth one is testing is context dependent. Seventh one is absence of error fallacy. So for all these software testing principles, we'll learn about all the principles in depth one by one. Let's begin with testing shows the presence of defects. The test engineer will test the application to make sure that the application is bug or defect free. While doing testing, we can only identify that the application or software has any errors. The primary purpose of doing testing is to identify the number of unknown bugs with the help of various methods and testing techniques, because the entire test should be traceable to the customer requirements, which means that to find any defect that might cause the product failure to meet the client's needs. By doing testing on any application, we can decrease the number of bugs, which does not mean that the application is defect free, because sometimes the software seems to be bug free while performing multiple type of testing on it. But at the time of deployment in the production server, if the end user encounters those bugs which are not found in the testing process. Next is exhaustive testing is not possible. Sometimes it seems to be very hard to test all the modules and their features with effective and non-effective combination of the input data throughout the actual testing process. Instead of performing the exhaustive testing, as it takes boundless determinations and most of the hard work is unsuccessful. So we can complete this type of variation according to the importance of the modules, because the product timelines will not permit us to perform such type of testing scenarios. With the help of below example, you can know more about exhaustive testing. Like we have a web application which have 20 screens, and here you can see 4 menus, 3 options. Okay, so average is 10 fields per screen, 2 types input and fields. So total for exhaustive testing will take, we have to test this much scenario. So if 1 second per test, 8000 minutes, 133 hours, 17.7 days. So it means 10 seconds is equal to 34 weeks, 1 minute is equal to 4 years, 10 minutes is equal to 40 years. So this much test scenarios will take 40 years to test whole screen. So this is all about exhaustive testing. Next one is early testing. Here early testing means that all the testing activity should start in the early stages of the software development life cycles. Requirement analysis stage to identify the defect, because if we find the bugs at an early stage, it will be fixed in the initial stage itself, which may cost us very less as compared to those which are identified in the future phase of the testing process. To perform testing, we will require the requirement specification documents. If the requirements are defined incorrectly, then it can be fixed directly rather than fixing them in another stage, which could be the development phase. Next is defect clustering. The defect clustering defined at Throughout the testing process, we can detect the number of bugs which are correlated to a small number of modules. We have various reasons for this, such as the modules could be complicated, the coding part may be complex, and so on. This type of software or the application will follow the Pareto principle, which states that we can identify that approx 80% of the complications is present in 20% of the modules. With the help of this, we can find the uncertain modules, but this method has its difficulties. If the same tests are performing regularly, hence the same test will not able to identify the new defect. When a small number of modules contains most of the bugs detected or shows the most operational failure. This is the main for defect clustering. With the help of below image, you can see this is defects. Okay, green one is good chip and bad one is red one is bad chip. This is unclustered defect, and when you clustered it, this is clustered defects. So this is all about defect clustering. Next one is pesticide paradox. The principle defined that we are executing the same set of test cases again and again over a particular time. Then these kind of the test will not be able to find the new bugs in the software or the application. To get over these pesticide paradoxes, it is very significant to review all the test cases frequently. And the new and different tests are necessary to be written for the implementation of multiple parts of the application or the software, which help us to find more bugs. The next one is testing is context dependent. Testing is a context dependent principle states that we have multiple fields such as e-commerce website, commercial website, and so on are available in the market. There is a definite way to test the commercial site as well as the e-commerce website because every application has its own needs, features, and functionality. To check this type of application, we will take the help of various kind of testing, different techniques, approaches, and multiple methods. Therefore, the testing depends on the context of the application. Next one is absence of error fallacy. Once the application is completely tested and there are no bugs identified before the release, so we can say that the application is 99% bug free. But there is the chance when the application is tested beside the incorrect requirements, identified the flaws and fixed them on a given period would not help as testing is done on the wrong specification, which does not apply to the client requirements. With the help of below figure, you can see what the client really need and what operations install. The absence of error fallacy means identifying and fixing the bugs would not help in the application is impractical and not able to accomplish the client's requirement and needs. So this is all about 7 principles of software testing. But don't forget about almost the most important thing. Sometimes testing and searching for functional bugs, we forget to look at the other side and ask if the user needs it. If this feature does not meet the user's expectation and needs, then no matter how high quality our product is. So we need to understand each and everything, then we'll go for doing the testing. Thank you.